Hello everyone, welcome back to Botany class. In previous videos, in ecosystem chapter, we discussed up to productivity, nothing but one of the function of ecosystem. I hope that until now you understood everything. And in this video, we will further continue. And the topic what we are going to discuss in this video is we are going to see the remaining function of ecosystem like decomposition and energy flow. First we'll start with the decomposition. Actually decomposition nothing but exactly it's a process of breakdown of complex organic matter into simple organic matter, and then further they are converted into simple inorganic raw materials. Like you can say, so you see whatever organic, okay, after death of the plants, after death of animal, their bodies are added to the soil. The body mainly composed of organic compound than the inorganic. And inorganic compounds also present. But in decomposition meaning is the breakdown of this complex organic matter into simple organic matter, and further they are broken down into inorganic raw materials like CO2, water, and other inorganic nutrients. And who will carry out this particular reaction or particular decomposition by group of organism? The group of organism together you can call it as decomposer. The group of organism together you can call it as decomposer, right? And so the main site of decomposition is where the decomposition will take place. Exactly in the ecosystem, where the decomposition will take place. For you take example, forest ecosystem, there are three layers are there, main layer, bottom layer, middle layer, top layer. But in forest ecosystem, if the dead organic matter undergoing decomposition, where exactly it takes place? Decomposition will take, the main site of decomposition is upper layer of the soil, whatever ecosystem, right? And in upper, for example, if it is terrestrial, it is the upper layer. If it is aquatic ecosystem, it's a bottom of the water body or bottom of the aquatic ecosystem. Okay, these are the main site of decomposition, right? You keep in mind the main site of decomposition is if it is terrestrial ecosystem, the upper layer of the soil, and if it is aquatic ecosystem, the bottom layer of the water bodies, right? Like you can see here, the dead remains like leaf, bark, and branches, flowers, and dead remains of animals. That everything may be together, it's formed together. You can call it as detritus. Detritus. The detritus is it's a raw material for decomposition. Detritus is raw material for decomposition, right? You can see the image here. Everything is dumped here, like fruits, vegetables, and the remains of plants, leaves, everything. They start to decompose. Okay, they start to decompose. This all the dumped item, the garbage, you can call it as detritus. The detritus is raw material for decomposition. But in process of decomposition, there are three important steps are there. Three important steps. So one is fragmentation. Fragmentation. Second step is leaching. Third step is catabolism. Actually, these are the three major steps of decomposition. And in this process, the whatever organic matter dumped on the soil surface or maybe deposited at the bottom of the water body, they undergo decomposition. Finally, they are converted into simple organic matter, or for complete degradation, they are converted into inorganic material like CO2, water, and other inorganic nutrients, right? But what are the main steps involved in this process? Fragmentation, leaching, and catabolism. But all this process occurs one by one. So first fragmentation followed by leaching, a leaching process followed by catabolism, right? And we will see the exact the steps of the decomposition here. First step of decomposition is it start with the decomposition process start with fragmentation. Like detritus is there, so detritus start to fragment, right? Like is for example, and this particular fragmentation is carried out by the organism are small invertebrates animals. This organism name is called detrivores. Detrivores. These organisms they start to feed on this detritus. Okay, detritus. For example, earthworm, termites, etc. These are their small invertebrates animal. The animal without backbone. They start to feed on this detritus, and they fragment. What they will do now? So they bring about it fragmentation. Fragmentation nothing but the complex organic matter are converted to simple organic matter. The process of conversion of complex organic matter into simple organic matter, you can call it as fragmentation. This fragmentation is carried out by small invertebrates animal. The small invertebrate animal, you can call it as detrivores. Detrivores. So actually the part of detritus eaten by detrivores, and they come out highly pulverized state in their fecus. Pulverized nothing but the granulate state, right? And fragmentation followed by leaching. Like you see, so the decomposed matter is there. If your decomposed left in open area, what will happen is the part of the water soluble substance, whatever present in that fragmented and decomposing detritus, they go down into the soil horizon. Okay, you see, we left the decomposed material or the manure in the open place of the soil or upper part of the soil layer. When rains will come, what will happen is whatever the organic compounds are present, if it is soluble, they solubilize in this water and then they go down into the soil horizon by percolating water and get precipitate as a unavailable salt. But which compound they go down? Mostly sugars and some inorganic nutrients. If they are soluble in water, they go down and they get precipitate and they precipitate as unavailable salt, right? Third step is catabolism. The catabolism is carried out by saprophytic bacteria and fungi. Okay, you see, first two steps, fragmentation, leaching. Okay, there is a small animals only, but catabolism is mainly it's a carried out by saprophytic, the bacteria and fungi. Why we are saying this is saprophytic organism? They can feed on dead and decomposing matter. So how they can carry out this one? They produce some digestive enzyme. This digestive enzyme, with the help of that, they can convert this complex organic matter into simple compounds like inorganic substance. And this inorganic substance, they are further released in this process, right? Be clear with this? So the group of bacteria and fungi are called saprophytic. Thus they can feed on dead and decaying organic matter. How they can convert this dead and decaying organic matter into simple organic matter and further into inorganic by secreting some digestive enzyme over the fragmented detritus. These enzymes they convert complex organic compound into simple organic, and further they are converted into inorganic substance. Okay, so that's why the catabolism also we are calling as natural scavenger. Natural scavenger meaning is they are helping to reduce the quantity of the garbage or organic matter which dumped on the open space or in soil, right? That's why we are saying that natural scavenger. So next we can see the different decomposition produces mainly when the organic matter undergoing decomposition by either by first the fragmentation, leaching and catabolism process. But this process produces two types of substances. One is a humus Another one is inorganic nutrients. One is a humus, another one is inorganic nutrients. The process of conversion of this organic matter into humus and inorganic nutrient, that process name is called humification and mineralization. So suppose the decomposed organic matter is there, the decomposed organic matter further converted to humus. The process name is called humification. Further they are converted to inorganic nutrients. That process you can call it as mineralization, right? First we will see what is exactly humification. Here the detritus is there. Detritus contain mainly complex organic or maybe simple organic compound. So by humification process, these complex organic or simple organic matter are converted to form humus. And what is that humus? How it look? Na? Humus is dark colored substances and amorphous. There is no specific morphology, right? And which is rich in cellulose, lignin, tannin, and resins. So these are the main organic compounds which are found in the humus. It is a highly resistant to microbial action. Okay, actually, if the humus persists on earth or soil for long duration, because the microorganisms which are highly resistant to microbial action, so that this particular one they slowly undergo decomposition, slowly mean at extremely slow rate, and this humus is slightly acidic, colloidal, and this humus function as a reservoir of nutrients, right? Again, one more time we'll repeat. The decomposition process, they convert detritus into humus. Humus is dark colored amorphous substance which is rich in cellulose, lignin, tannin, and resins, which is highly resistant to microbial action. It is undergo decomposition at extremely slow rate, and humus is slightly acidic and a colloidal one, and its which function as a reservoir of nutrients to the plants. You see here humus, wherever we are discharging our the waste water from kitchen or from restroom or bathroom, where the water is discharged, you find that area soil become whatever color, it become black color. So black color, why it converting to black color now? Because decomposition of this organic matter and a further formation of humus. That black color is nothing but it's a humus, right? And next one is mineralization. It is a process of release of inorganic substance from organic matter or from humus. You see, humus and all, humus also rich in only organic only. And organic matter is there, directly the organic matter decomposed and converted into inorganic nutrients. So that the process from wherever it may be, directly the minerals are released from organic matter or maybe humus. So that process name is called, you can call it as mineralization. It's a release of inorganic substance like minerals, water, CO2, either from organic matter or humus during the process of decomposition. That process name is called mineralization, right? And next we have to see what are the factors which affect the decomposition process. So decomposition is purely biological process, but the rate of decomposition of detritus may be affected by number of physical as well as chemical factors, right? So the mainly the rate of decomposition of detritus is which is controlled by chemical nature of detritus, and not only chemical nature and also other the environmental factor also responsible, right? Here we are going to discuss what are the chemical factors, what are the environmental factor which affect the rate of decomposition process. First we will see here chemical nature of detritus. Chemical nature of detritus, actually the decomposition detritus is slow if it contain more amount of the organic polymers like lignin, chitin, tannin, and cellulose and the phenolic compound. Okay, if they are decomposing the detritus is which is rich in this material, then which limit the rate of decomposition. The decomposition process will proceed very slowly. When it happen at rapid condition, if a rate of decomposition when it increases, detritus possess more nitrogenous compounds, right? Like protein, nucleic acid, and other water soluble carbohydrate or sugar. Okay, see, when the rate of decomposition is very slow, if the material detritus is which is rich in lignin, chitin, tannin, and other cellulose. When the process is rapid, detritus process which is rich in organic nitrogenous compound like protein, nucleic acid, water soluble carbohydrate, and sugar. Okay. So next one is temperature. If temperature is more than 25 degrees Celsius and the decomposition process it occurs at very fast. So because the condition which favors the it's optimum temperature for decomposition. And also if under low temperature condition, if below that 25 or minus 10 degrees Celsius of soil, the rate of decomposition is very slow, even if moisture and aeration also optimum. Okay, you see, there are three important conditions here they are discussing. The soil having good moisture and aeration. If temperature is optimum for decomposition, then the decomposition process is so rapid. The temperature is low, the soil moisture and aeration are good, so optimum, then also the rate of decomposition is very slow, right? And next parameter you can see moisture. Optimum moisture which help in quicker decomposition of detritus. If moisture is there, then they undergo rapid decomposition. Like you see in summer, so most of the plants they fall off their leaves. You can find all the leaves which settle at the bottom of the tree, they form detritus. When these leaves they undergo decomposition, when rain starts, that area become moisture. So the moisture help in decomposition of the fallen leaves, right? And the reduction moisture reduces the rate of decomposition, which reduces the rate of decomposition, right? And aeration, it is required for activity of decomposer and detritivores. Required for activity of decomposer and detritivores, and it reduces aeration, will slow down the process of decomposition, right? Actually, most of the decomposing organisms are detritivores or decomposer, they are aerobic, except some saprophytic bacteria, fungi. If aeration conditions are good, then the decomposition process also very rapid. And if the aeration is reduced, so which slow down the process of decomposition. Okay, you see the final very important point here is warm, moist environment to favor decomposition. Wherever place is very warm and moist condition is more to favor the decomposition process. Whereas low temperature and anaerobic condition, the aeration is very less, which inhibit the decomposition. So if decomposition is inhibited, then result in buildup of organic material, right? This is a very important point. Warm and moist environment, which favor the process of decomposition, and whereas the low temperature and anaerobic condition inhibit the decomposition process. If further the material is not decomposed, then which organic material may be built up in that particular area, right? I hope that you understood decomposition process. The next topic is energy flow. The energy flow is nothing but it's a sequential process. The movement of energy from one level to next level in an ecosystem. Like how the energy will move from one level to next level through series of organisms. Series of organisms, how we can say energy enter into the producer and then start to move to primary consumer. From primary consumer next goes to secondary and tertiary and top carnivores. Like the sequential process of movement of energy in an ecosystem through series of organisms, you can call it as energy flow. And whatever may be, the sun is for all ecosystem except deep hydrothermal ecosystem. Remaining all ecosystem, sun is the only source of energy, right? You keep it in mind for all ecosystem, but only one exception is deep hydrothermal ecosystem. For remaining all, the sun is the only and the sole source of energy, right? And how you look this flow chart here, how the energy is flowing. You are getting 100% solar radiation from the sun. That is the incident solar radiation from sun is 100%, right? And then from solar, it's reaching the outer surface of the earth. And in that, 50% of, less than 50% of the incident solar radiation, we can call it as photosynthetically active radiation. Why this 50% we are calling as photosynthetically active radiation? These solar radiation are available to the green plants to carry out photosynthesis. So out of 100%, less than 50% is PAR. PAR meaning is photosynthetically active radiation. What about remaining 50% or more than 50%? This more than 50% of incident solar radiation is absorbed by gases and water vapor. Some percentage may be absorbed by gases and water vapor in the atmosphere. Some percentage may be reflected by the clouds. Some may be scattered by dust particle. So like this, the more than 50% is not reaching the or not available to the plants. So the percentage of incident solar radiation available to plant is less than 50%. That less than 50% available incident solar radiation to the plants or for the plants, can call it as photosynthetically active radiation, right? And here they are out of 50%, plants can able to store, capture and convert this energy into food is only 1 to 5%. Okay, and the remaining loss is 45 to 49%. 49 to 49%, because full day we are getting sunlight, and I told from whatever the radiation we are getting from the sun, we are not getting completely. So the atmosphere, the surface we are getting only less than 50% only. But plants unable to capture the whole the light whatever getting, so that the plant able to capture and convert this energy, or maybe able to use this energy to synthesis food is only 1 to 5%. So remaining is not utilizing, only remaining waste is 45 to 49. And out of 1 to 1.5, it's a producer. So the respiratory loss is 0.21%, and the amount of energy available in producer for the consumer is only 0.8 to 4%. So this much energy, it's a GPP, which are stored by or which are synthesized by the producer or green plants, and they can consume whatever they are taking from sun, consume 0 to 0.2 to 1% as a respiratory loss for respiration purpose. The remaining available energy for next level consumer is from producer is 0.8 to 4%. Okay, these parameters are very important. Keep it in mind, right? And next we can see the energy flow, source of energy we will see. Actually, energy does not remain trapped in permanent in any organism, right? So they are keep on flowing, they keep on moving from one level to next level, like producer, primary consumer, secondary, tertiary, top carnivores. Okay, this energy from producer pass into the next high tropic level. Okay, what is the tropic level? This producer, primary consumer, secondary consumer, tertiary consumer. Producer considers a first tropic level. Primary consumer considers a second tropic, third tropic. This is a high tropic level. and energy traveling from sun, it's entering into producer, next flowing into the next moving from producer to consumer, and finally reaching the tertiary consumer. Whatever energy available to tertiary consumer, that maybe this become available to detrivores or decomposing organism after organism will die. Like you can see here, the sunlight from the solar radiation from sun is captured and converted to food by producer. The herbivore which is feeding on, so you see this much energy is captured, and the herbivore feeding on this producer, when they are feeding on producer, the part of energy may be wasted because we are taking food. So whatever food in that, whatever calories there, some calorie used for our catabolic process, okay, assimilated, and then some calories herbivores, okay, stored in the food. These herbivores are eaten by carnivores. There is nothing but secondary consumer. Some energy transferred here. Again in carnivores, some energy lost through respiration. And finally, top consumer, carnivore. So that energy from one by one is flowing, so that nearly 90% of energy is lost, only 10% of energy is transferred to next level. So we are going to discuss this energy loss in coming section. There is a 10% of energy loss. Okay, so that the energy passing from autotrophs to the next level, top carnivores, and after tertiary consumer or high trophic level consumer, this energy may be used up by the detrivores or decomposing organism, right? And the energy flow in an ecosystem which follow law of thermodynamics, right? This law of thermodynamics we are studying in physics as well as in chemistry. The expenditure energy in the ecosystem is based on two important, or which follow two important laws of thermodynamics. One is the first law of thermodynamics, second one is second law of thermodynamics. What is that first law means? Which state that energy is neither created nor destroyed, but can be transformed from one form to another. The energy from sunlight enter into the producer, but producer to next level, how it transforming na, the energy in the form of solar radiation here transformed into food, and then they are transferred to the next level. And how the energy losing na, by heat, right? One form to another form, but energy is it's not destroyed, right? And the second law of thermodynamics, the no transfer of energy occur unless until it is accompanied by degradation or dissipation of energy from concentrated to dispersed form. Like you see, when energy transferring from one organism to another is accompanied by degradation, a loss of major part of the energy, as already we discussed in previous slide. Okay, here you can see how much energy is stored in producer, but only some percentage only stored in herbivore. The remaining part is loss. The herbivore to carnivore, only some percentage only transferred. Remaining is respiratory loss. The carnivore to, here secondary consumer to tertiary consumer is only some percentage, right? That's given in second law of thermodynamics. The energy the transfer of energy from one organism to another organism is accompanied by degradation, loss of major part of food energy as a heat. So that the energy flow, the energy flow of ecosystem, of any ecosystem, follow this first and second law of thermodynamics, right? So up to this I will end up, and further topic we will discuss in next video. Thank you.